Hi, I'm Anjali Vasan. Today I'm going to present my internship project on microcontroller-based washing machine simulation using PICSimLab. And these are our contents are project overview, embedded system, introduction to C, microprocessor and microcontroller, working, block diagram, peripherals and tools, output and conclusion. This is our project overview. This project simulates a microcontroller based washing machine using PICSimLab. The user interacts with the virtual buttons. Here, the virtual button refers to powers, navigation, start or stop, and view machine status on a virtual CLCD. The machine status may be a program, timer, door alerts, etc. In this project, the core logic is it is written in C and compiled with MPLAB X8. It controls virtual motor and buzzer output, a real washing machine's operational cycle. Embedded system. An embedded system is a specialized computer designed to perform a specific task within a larger device. And it integrates the hardware and software, often operates in real time, and it is optimized for efficiency and reliability. And the application of embedded system as shown in the figure, that is manufacturing equipment, domestic appliances, audiovisual equipment, gaming consoles, telecommunication equipment, medical devices, cars and vehicles, and motion sensors. Introduction to C. C is a high-level general-purpose programming language, and it is developed in 1972 by Dennis Ritchie. It's known for its speed, efficiency, and close-to-hardware capabilities. And it is widely used in system software, embedded system, and operating system, etc. And the key features of C is it is high performance, portable, low level access, efficient memory management. Data types. Data types specify the kinds of value a variable can hold and the amount of memory it occupies. The general syntax of data types are shown: data type underscore variable name semicolon. Data types are three types. Primary data type like int, char, float, double void. Derived data type array, pointer, functions. User defined data type structure, unions and numerations. Operators. What's an operator? Operators are a special symbol that perform operations on one or more operands. The operands may be a variable or a value. There are different types of operators like arithmetic operator, relational operator, logical operator, assignment operator, increment or decrement operator, pointer, size of, comma operator, etc. Next is control flow statement. The control flow statements are divided into three categories: conditional statement, iteration statement or looping statement, and gem statement. The conditional statements are if else, nested if, switch case. The iteration statement while, do while, for. Gem statement break and continue. Conditional statement in C, that is if else. If else is categorized into four: if else, if, nested if. And the syntax are shown. And the another one is switch. Loops in C. For loop is used when the iteration is known, that it initialize the variable, check condition, execute body, update variable, repeat or exit. While loop check condition. If true, execute the body, update variable, repeat or exit. Do while, execute body, check condition. If true, repeat or exit. The another one is jump statement. Jump statement is mainly break, continue, return and go to. Arrays. Array is a collection of elements with same data type. It allows for the storage of multiple values under a single variable name and which can be accessed using its syntax. The general syntax of arrays are shown: data type, array name and its size. String. String is a null terminated sequence of character stored in a character array. The syntax is char string name size semicolon. Pointers. A variable that stored the memory address of another variable. The general syntax of pointers are shown: data type dot pointer name. Next one is functions. A self-contained block code that performs a specific reusable type. Declaration means function declaration. That's return type, function name and parameter, let's semicolon. And function definition is the actual code block. Function calls execute the function. Parameters passes by value or reference. Return values return send a result back or void. Storage classes in C. Storage classes in C programming define the scope, lifetime and storage location of variable and functions. The storage specifier are auto, extern, static and register. And the auto is stored in stack and the initial value is garbage and the scope is within the block and life is end of the block. In extern, the storage is data segment and the initial value is 0 and the scope is global multiple flights and life is till end of the program. Static is also stored in data segment and the initial value is same as extern like 0 and the scope is within the block and life is till end of the block. Register. The storage is CPU register and the initial value is garbage and the scope is within the block and the life is end of the block. Preprocessor. Preprocessor is the first phase of compilation. It processes the code before the compiler, handling directives starting with hash, like hash include, insert the content of another file like hash include stdio.h, and hash define. It creates the macros. Conditional compilation, include or exclude the code block based on condition, and generates modified source code that is fit to the actual C compiler. Memories in C. Segment. The memory is divided into stack, heap, data and text. Allocation type is it is either automatically managed or dynamically managed. Dynamic function is malloc, calloc, realloc, allocate, free, deallocate. And the programmers have direct memory control requiring careful management to prevent leaks and errors. And the figure shows microprocessor and a microcontroller. What's the difference between a microprocessor and a microcontroller? In microprocessor, it has only CPU embedded on it, but in case of microcontroller, it has CPU, RAM, flash and other peripheral embedded into it. The application of microprocessor is in computer system and in microcontroller is embedded system. Microprocessor is large scale processing and microcontroller is small scale processing. And the microcontroller is used in Arduino, STM32 and MSP432 etc. But in case of microprocessor, it used in PC, mobile phones, Raspberry Pi, etc. This is our block diagram of our project. Microcontroller, here we are using PIC16F 877A, power on, pause and stop, navigation, door status, CLCD means character liquid crystal display, buzzer and a motor. The working is, the CLCD shows the press key 5 to power on. When we press on switch 5, it confirms powering on. We can see in washing program screen. The washing program screen shows the program list like daily, heavy, woolen, cottons, bed sheets, etc. like that. When we want to scroll the program list, press switch 4. Again, long press on switch 4. We will go to the water level screen. In water level screen, it displays auto, low, high, medium like that. If you want to scroll, short press on switch 4 and long press on switch 4, then it will go to the start screen. In start screen, we can show two switches, switch 5 and switch 6, and switch 5 to machine to start and display program time, and switch 6 to returns the program screen. In the function screen, it shows the current function and its time. When we press on switch 1, the door gate opens and the machine pauses buzzer sounds. In switch 6, it pauses, and switch 5, it resumes the operations. And the cycle continue until the time completes. The completion status screen shows the program completed, remove the clothes, and then it will go back to the washing program screen. Peripherals and tools. Microcontroller. Here we are using PIC16F 877A, that is shown in the figure. It is 8-bit RISC CPU, efficient, 32 instruction up to 20 MHz. Memory is 8 KB flash and 368B RAM and 256 bytes EEPROM. Input output is 33 general purpose input output pins. Peripherals is ADC. ADC means analog to digital converter, timer, PWM, USART, SPI bar, I2C. Features: ICSP, WDT, sleep mode. The wide operating range is 2.0 volt to 5.5 volt. The application is general embedded control like in robotics or educational project like that. This is the architecture of PIC16F 877. It contains a program memory, program counter, and the data bus are shown. EEPROM data memory, RAM file registers, address multiplier, file select register, multiplexer, arithmetic logical unit, working register, instruction code and control, instruction register, and several ports are shown, that is port A0 to A7, B0 to B7, C0 to C7, D0 to D7, and E0 to E2. Switches provide user input and safety to the simulator washing machine. They connect the microcontroller pins dictating the machine's behavior. Buzzer. It provides the sound allowed to user. Signals when washing is complete. Indicates false or important status. Motor. The washing machine drum motor simulate for different speed and direction like wash, rinse, spin, spin per wash, and spin cycle. It illustrates microcontroller motor speed and direction control. Timers. It controls the exact length of each stage, ensures the action occurring in the correct order, drives overall automatic progression of the washing cycle. Digital keypad is more option for user selection. It's reduced microcontroller pins needed for multiple buttons and improved realism. LED. It shows machine status, light up, show active cycle phase, provide instant visual clues. And CLCD. It displays the text for status, time, program. CLCD means character liquid crystal display, and it shows the specific operational detail for debugging and actual washing machine displays. These are the tools we are used in this project: MPLAB XT compiler, MPLAB XAID, and PICSimLab. This is our output. I will show you our program. MPLAB XID. This is our project washing machine. We have header file like CLCDH, digital keypad, main, timers, washing machine. In the source code, we write the actual program. CLCDC, digital keypad, main, timers, washing machine definition .c. Here is our program. Washing machine definition function. Let me build the program again. Build project washing machine. Building successful. Then we have to open PICSimLab. File, load hex, washing machine X project. Press key 5 to power on washing machine. I am pressing key 5. The washing machine powering on, and then it go to the washing program screen. When we short press on switch 4, it will scroll, and long press on switch 4, it will go to the water level screen. In water level screen, again long press on switch 4. If you want to scroll, short press on switch 4 also. It will go to the start and stop. If you want to stop, it will go back. Press switch 6 heavy. Again I am long pressing. I am pressing switch 5 to start a program, dedicate, and it's time, and the program is running. When I switch 1, door open, please close, assuming that. When I press switch 6, it will pause. To resume, switch 5. Again it's running. The function is changed to rinse and then to spin. Program completed. Remove clothes. And it will go to the washing program screen. This is our project output. And this is our output. Conclusion. A microcontroller-based washing machine simulation using PICSimLab offers a cost-effective, rapid, and safe platform for designing, testing, and learning embedded systems, specifically by visual replicating washing machine functionalities without a physical hardware. This is our overall of our project. Thank you.